We are talking about probability in mathematics. So, what is probability? Means, if I toss it, okay, so, okay, so if I toss a coin, then what is the probability that it will be head? So, in probability, there are two things. One is sample space, how many samples we are creating, and in the sample space, how many we want. Okay, sometimes it is called that solution is hidden in the problem. If we are able to analyze the problem neatly, minutely, intricately, solution is hidden in that. Okay, so no need to look at other places for the solution. Many times solutions are hidden in the problem itself. So, what is the probability that if I am tossing a coin, then it is head? Okay, now how means what is the sample space we are talking? So, the sample space is head and tail. I am not saying either head or tail. Head is one sample, tail is one sample. Now, out of these, how many I want? I want only one. So, 1 by 2. If I toss it 3 times, 1 time, 2 times, 3 times, okay, what is the probability that I get head, head and head? Okay, if we see the books, then there are lots and lots of formulas are there, like dependence, independence, and then factorial, and then then it comes to like a matrix false positive or false negative, and then sensitivity and specificity, and so many things. Okay, so if I am tossing a coin 3 times, then what is the what is the probability that I'll get head and head in 3 times? Okay, what is the sample space? How many sample space we are generating? So one sample space is head, head, head. Another is head, head and tail. Another is head, tail and head. Another is head, tail and tail. Another is head, tail and head. Then another is head, tail and tail. Another is tail, head, head, tail, head, tail. Tail, tail, head, tail, tail, tail. Okay, so there are 8 sample spaces. Now I say it is mutually exclusive and this and that, and then it is 2 to the power 3 and something like that. But okay, so if I am tossing 3 coins, it is equivalent to I have, okay, so I have 3 coins in my hand. I think I can show it. So there are 3 coins in my hand, and if I toss it, then what is the probability that it is head, head and head? Same thing. If I toss a coin 3 times, or I have 3 coins in my hand and I toss, okay, then what is the probability that it will be head, head and head? So probability is what is kind of how many sample space we are generating, and out of those sample space, how many we are picking. So we are generating 8 sample spaces. If we are generating 8 sample spaces, 1 we are head, head and head. So that is 1 by 8. So getting the probability of head, head and head is 1 by 8. If I toss it 2 times, then we are generating four kind of sample space. In sample space, four items are there. One I want. Now mutually exclusive and this and that. If I toss this coin, then if head comes, then only I toss this coin. Then if this comes, then formula. You just sit back and think in your sample space how many items you are getting. Okay, generate the sample space, and once you are done with generating the sample space, then now decide which one you want, how many you want, so which all you want, and count by whatever items in count. So solution is hidden in the problem. If I have a clear problem space, if I understand the problems in probability, the biggest thing is that people do not understand the problem. What is the problem? If problem is identified, then getting to the number of items in the sample, or if problem is identified, then getting item in the sample, then picking the items what we want. So solution is hidden in the problem itself. Okay, so now a little bit kind of more hazy, overcast problems, like I believe this is a known problem and people they know it. So like at a place or in a city, in a town, at a place, so car kind of there are taxi and they kind of they are deployed, they serve people. And 15% of the taxi is blue and 75% of the taxi is red, or it is not blue. 15% are blue and 75% are not blue. It may be red, it may be green or yellow. So many things. Now, in a kind of, there is a hit and run case, and it's a dark, and then one person is kind of his eyewitness, and now he is saying that the hit and run case, that taxi is blue. So there are 15% taxi in city, those are blue, and in hit and run case, he found that the taxi is blue. This is one case. Now let's see simple case. There are 15% taxi in city are blue. In a hit and run case, what is the probability that the taxi is blue? This is one question. In a hit and run case, what is the probability taxi is blue? So every 100 taxi, 15 is blue. So the probability that in a hit and run case the taxi is blue is 15 by 100. So it is 15%. 0.15 is the probability that. Now another question. Now a person is saying that he saw that taxi is blue. So we proceed on the question. Now that Mr. Judge, he is kind of, he is not very happy with his reply. Means it is a dark night, there are few light here and there. So it is a high chance that he may kind of identify it wrong. So it was tested. In the same kind of scenario, environment was generated, and it was found that 80% of the time he finds the correct color in that scenario. If car is red, then he is saying it is red. 80%. 20% scenario, he is saying something different. Now, what is the guarantee? Now, what is the probability he is saying truth? Probability has little bit degree, but there is no different kind of probability. So this falls in a kind of bias theorem, conditional probability. All probability are conditional probability. So bias theorem, like it talks if there are two events and they are orthogonal, they are not related. If angle between two, if I draw in vector diagram, an angle between two events is 90 degree, it is considered as orthogonal and they are not related. Otherwise they are related. Okay, to some degree they are related. That we have seen in our tutorial that the essence, like we saw the dot product and cross product. So essence will be there if we talk about if we talk about any angle, if it is not orthogonal. So if two events are orthogonal, then based upon the occurrence of one event, what is the probability that other event has occurred? Okay, if they are really orthogonal, then there is no probability. I mean, there is intersection. Little bit intersection is there. And then we try to find, means angle is not absolutely 90 degree. Okay, it tends to 90 degree. Okay, we will see many examples. Now we stick to this example. So 15% car are blue and person is identifying it is blue, but 80% of the case only he is identifying anything that is correct. Now, what is the probability that car, the taxi in hit and run case is blue? If I see the Bayes theorem, then in Bayes theorem, I say PA by B. If B has occurred, then what is the probability of A occurring? Conditionally B has occurred. Okay, so I say probability, all probabilities are conditional probability. Okay, if I am tossing the coin, I will not talk about the Europe and America. Okay, so I talk only about the coin only. So conditional is the coin, tossing up the coin. So there is nothing that is unconditional. Okay, but anyway, so it's good that there is a bias there. Okay, now can we create a sample space? Now we have 15% car as blue, and out of that, now he is identifying 80% as correct. What is the guarantee that he is talking true? Okay, now we come to as if car is identified as blue. Okay, this is sample space. Like if I am tossing 3 times, what is guarantee, what is probability that it is head? If that person is identifying a car, how many cars are blue, that is not the question. If a person is identifying a car as blue, then what is the probability that it is true? It is blue. So in Bayes theorem it will come as probability of blue by person identifying blue. Now, if I see blue cars, then 80% are only blue. So 20% are gone because he is not identifying it. Okay, so out of 100 car, 15 into 0.8. So that much car is only blue from that person's eye. And out of 85 cars, 20% cars are blue. Okay, so means this is what he is doing. So now 85% 85 into 0.2 and 15 into 0.8. That many cars he is saying it is. Out of which, how many cars are actually blue? 0.15 into 0.8. Okay, so in our sample space, we are not talking about out of blue what is the probability. How many cars are identified as blue? So in blue, there is a percentage of cars that is identified as blue, and in rest or in red, this much cars has been identified as blue. So the sample space item contains that many cars. Now in that many cars, we have to pick which one is actually blue. So 20% of the car in blue, actually it is not in the sample space at all. They are out. If they are not in the sample space, there is no meaning of finding solution inside that sample space. Okay, so probability is only one. You have to find the sample space, items in sample space, and pick the item what you want, and then just divide. Okay, 10% of people in the world, they talk English. 10% of the people. I mean, this is hypothetical data. Okay, I am saying, I don't know what is the actual truth. Okay, 1% of world's population lives in Egypt. Hypothetical data. Okay, whatever in the Egypt's population, 1% people they talk in English, means they are bilingual. They talk in Egyptian and they talk in English. If a person, okay, speaks English, what is the probability that he is from Egypt? This is biased. Now, condition is, now there are two orthogonal, means as per the Mr. Bias. So, one orthogonal, one vector is people in the world, they are speaking English. And one orthogonal vector is people in the world who are living in Egypt, means they are totally unrelated. People are speaking English and people living in Egypt, they are totally unrelated. Okay, but there is intersection. That's why there is a probability, otherwise there is no probability. Now, if someone is speaking English, then what is the probability that he is from Egypt? Okay, now, if I am saying the condition, so now, if I expand my sample space, so person is speaking English, so now it is simple example. It is simpler than car example, taxi. Now we find that how many people there they talk English. So 10% of the people they talk English. And now we will pick what we want. Okay. So 10% of the world they talk English. Okay. And 1% of the world they are from Egypt. Certainly there is intersection. Okay. Certainly there is. What we are talking is, what is the strength of the intersection by people who are talking English? So, in our sample space, all people who are talking English, they comes, and now inside that we will pick who are from Egypt. Okay. So if 10% people talk in English, then it is 10. Okay. One greatness about Bayes' theorem is actual amount is not required. Means we can work in percentages. Okay. But again, it is a subset of probability one. And probability is only one. Means you have to find a sample item. So I won't say that this way of probability you have to find like this and this way. So probability is found in only one. Okay. Now, if I know the sample space, inside that I have to pick how many people they belong to Egypt and they speak English. So 1% of the people they belong to Egypt. Inside that 1%. So it will come around 0.01%. So 0.01 by 10. So that is the probability. Okay. So probability is finding the sample space, items in sample space, and then picking up the item. There is a place where 10% of the people are corona positive at that moment. Hypothetical data. Okay. So there is a place that 10% of the people they have corona infection. Now, if a person goes to hospital to get tested that he has corona, okay, now 70% of the chance that he will be tested corona if he has corona. So kind of true positive. So if he has tested corona and actually he has corona. So if a person has a corona, 70% of the chance of the test success means success of chance of the success is means out of 100 corona patients, 70 corona patients are tested that they have corona, and 30% they are said you don't have corona. False. Okay. If a person he does not have corona and he goes for test, 90% of the chance is there that he will be tested negative, true negative, and 10% 10% chance is that he will be tested corona. So out of 100 people they are free from corona and they go for test, and 90% will be said that okay, you don't have corona, so you are kind of no need to be annoyed, and 10% will be given label as corona. A person is going for test and he is tested corona. What is the probability that he has corona? Okay, now we'll go for bias theorem and then mutual exclusive and then PA by B and then some sigma, okay, and then some pi and so many calculations. Not like that. Okay. Now think from the person. Now we have to generate that items in the sample space. We are saying a person is tested corona. What is guarantee that he actually has corona? How many people are being tested corona? That is the sample. That is difficult to find in probability. If you catch the sample space, if you catch the problem, then you have to just pick the solution. That's it. So, how many people are tested corona? Now I have 10%, I have 90%. 90% people they do not have corona. 10% people they have corona. If these people go for testing, then 90% would, then 70% would be accepted as corona. So out of this, 30% are rejected from the sample space at all. So only 70% are coming in the sample space. Out of 90%, 10% people are tested corona, even though they do not have. So 10% from the 90%, they are coming in sample space, and out of 10%, 70%. So here, out of 90%, the people who do not have corona, 10% are entering into the sample space of the corona. Out of 10% of the people who have actually have corona, 70% people are entering into the sample space. Now, I have a sample space. Inside that sample space, how many people, now he has actually, so how many people have actually have the corona? How many people actually have the corona by how many people are inside the sample space as corona, as per all the environment. Okay, so that would come around 10% of total people have corona. So 10% into 0.7 by 10% into 0.7 plus 90% into 0.1. So if a person is going for test and if he has been detected corona, then this much is the chance that he actually has the corona. So can we see the sample space, how it varies depending upon the kind of probability that all the events, corona and not corona, these are two events. All the events in the sample space, how they are being identified, correct? Means as per the bias theorem, there can be many theorems, not only bias theorem. There can be infinite theorems. So infinite scenarios will be there. This is one scenario. So we'll see that funny things that how probability we generate. But this is the core of mathematical probability. Just understand the problem, solution is just stay waiting for you. So that will